Okay, so here are the solutions to the homework assignment. So the first group of exercises ask us to find f of x and f of g of x and g of f of x. So number 12, f of g of x. So g of x, we're going to plug into there. So we're going to have the square root of x plus 2 quantity squared plus 1. So where we have x, we'll put parentheses, and inside the parentheses we put that. And you can simplify, you just have to be careful about the domain, that you lose the information of the domain. Here the domain says that x has to be greater than -2, so that this sum is always greater than 0. But once you simplify it, you get this. The square root of x plus 2 squared is x plus 2, so it simplifies down to this. But you have that x has to be greater than or equal to -2. You have to add that extra little bit on there to maintain the same information. And then you have g of f of x. So our g of x is this thing. So we have the square root of x. For x, we'll put parentheses, and then we'll substitute in the squared part. Now, when you simplify here, you don't have to worry about anything because the domain for this one is all real numbers. And so, because you're going to, even if you have a negative, it's going to square to a positive number. So you have a positive number plus a positive number, which is always going to be greater than 0. So this is good for all real numbers. Okay, so that was 12. What I'll do is I'll work each one and then I'll move them out of the way. I'll just delete them. So you can pause. Well, thought I could do that. Let's try it again here. Okay, 13. So we have f of g of x. So we take f of x and we put a parenthesis where the x is. So we get the square root of this thing plus 2. The argument is x squared plus 3. Now in this case, there's no simplification that you could do except remove the parentheses. And then you have g of f of x. So our g of x function is something squared plus 3, and that something is the square root of x. So you can simplify this. Square root of x squared is x, but you have to specify that x is greater than or equal to 0 so that the original domain of x, when you take the square root of it, is maintained, which says you have to have that greater than 0. Okay, number 14, f of g of x. So we take the f function, so we have the absolute value of something, x. Put that in, x plus 5. So we can take the parentheses away, cleaned up a little bit. The domain is all real numbers in all these cases, so there's nothing we have to put on there to show that any simplification doesn't reflect the correct domain. And then we have g of f of x, so we have 5 times x plus 1, but x is the absolute value of x. So again, we don't really have to do much here. We just have to get rid of the parentheses. So we have 5 times the absolute value of x plus 1. So that's at g of f of x. Okay, 15. f of g of x. So f of x is the cube root of x, but x is going to be x plus 1 over x cubed. So if you look at this, the domain here is this argument has to be greater than 1. I mean greater than negative 1. To make this thing so you don't get the cube. Well, a cube root, you can't have a negative answer. Cube root looks something like that. So it's okay to have negative numbers. So I think the only case here is that x cannot equal 0, but even in the simplified case, it has the same restriction. So what you can do is you can take the cube root of the denominator. So you keep the cube root in the numerator, but take the cube root of the denominator. So the cube root of x cubed is x. So that's the simplification. And the other way around, g of x is x plus 1 divided by x cubed. But instead of x, we put in the cube root of x. So the simplification here is we can cube the cube root of x cubed is x, so this becomes the cube root of x plus 1 divided by x. And x cannot equal 0 here, and x cannot equal 0 here from the domain perspective. I guess we do have this additional thing that x has to be greater than negative 1. Greater than or equal to negative 1. That's so that we get a... Oh, I keep forgetting this is cube root, not the square root, so either always fine. Okay. (16) f of g of x. So we get 1 over something minus 6. And that something is 7x plus 6. Now to simplify this, it's not too bad because this 6 cancels out with that 6. And so you have 1 over 7 over x, or x over 7. So you take the reciprocal of this. 1 divided by 7 over x is just x over 7. And then you have g of f of x. So we have g of x is 7 over x plus 6. But instead of x, we put in 1 over x minus 6. Now again, to simplify this, what we do is we take 7, and instead of dividing by 1 over 6, we divide by x minus 6 over 1. And then we add the 6 to it. So I'm just taking the reciprocal of this, multiply it out. So we get 7x minus 42 plus 6. 7 times 6 is 42, negative sign. So that's 7x minus 36. 42 minus 6 is 36. And then the last one's kind of like this one, 17. F of g of x. So it's 1 over something minus 4. That something is 2 over x plus 4. So this cancels out that, and we end up with 1 over 2 divided by 1 divided by 2 divided by x. So again, you take the reciprocal of that. That simplifies it. And g of f of x is, well, g of x is 2 over something plus 4. That something is 1 over x minus 4. Thinking, did I do something wrong in the previous problem? No, I don't think so. Okay, we're okay. I was just... So again, you can take the reciprocal of this, which is just 1 over x minus 4. The reciprocal is just x minus 4 over 1 plus 4. So you multiply that out, you get 2x minus 8 plus 4, which is 2x minus 4. So that's the answer for that one. Okay, so that's the first group. The second group is we're asked to find f of g of something. So the way you do this is this is the g function over here. And we find the value of g at x equals 3. So here's x equals 3. The g value is 4. Then we take this 4 to here, and I'll use that output of the g function as the input for the f function. So I'm just going to go through the explanation here. So you take g of 3 is 4. Take that 4, put it down here. F of 4 is 0. Okay, the next one is f of g of 1. So we go over here. This is the g function, g right there. So g of 1 is 3. F of 3 is 2. So don't just copy these down. Make sure you understand what I'm doing. Okay, next one is g of f of 1. So we do f first. So f of 1 is 3. G of 3 is 4. So we said is f of 1 is 3, right? F of 1 is 3, and then g of 3 is 4. That's how we get the answer. Here's g of f of 0. So we do f of 0, which f of 0, here's x equals 0. F of 0 is 4. And then we do g of 4. So 4 is 5. So the answer is 5. Now you can do this on the same graph. So this is the f graph. So f of 5, so what we do is f of 5. F of 5 is 1, and then we do f of 1. So f of 1 is 3, so that's 3. Same kind of deal here. F of 4 is 0. And then f of 0 is 4. Now over to the g graph, we got g of 2. So we do g of 2. G of 2 is 0. And then we do g of 0. G of 0 is 2. And the last one we got g of 0. So we do g of 0 is 2. And then we do g of 2, which is 0. So it's 0. So you can see how we take the inside function, just go to the graph, take the output of the first function and apply it as the argument for the second function. In this case, we do the same thing. We just use tables instead of graphs. So let me leave a little space here so we can do our intermediate stuff. So what we're going to do here first is g of 8. So here's g, here's 8. So g of 8 is 4, and then we do f of 4. It's used there. So f of 4 is 4. So the answer is 4. Okay, next one, g of 5. So here's 5. G of 5 is 8. Then we do f of 8. So 8, f of 8 is 9. The next one, f of 5. F of 5 is 0. Then we do g of 0. G G of 0 is 9. Okay, f of 3. 3 is 8. G of 8 is 4. Now these are the ones where we do both of them with the same function. So we do f of 4. So f of 4 is 4. So we do f of 4 again, because that's this number is that number. So we know that's 4. Okay, so f of 4 is 4, but then so this is 4. Then we do f of 1. So f of 1 is 6. And then we do f of 6. So f of 6 is 2. So f of 1 is 2. Here we do g of 2. G of 2 is 6. So then we do g of 6. G of 6 is 7. Check that out. G of 2 is 6. G of 6 is 7. And then g of 6. So here's 6. G of 6 is 7. And then we do g of 7. G of 7 is 3. So the answer is 3. And the final one is, instead of having, you can use a graph table or you can use a function to do the same thing. So what we'll do here is for 72 we'll do g of 0. So here's the g function. So it's going to be 7 minus 0 squared. So g of 0 is 7, and then we'll do f of 7. So use the output of this as the input of this. So the f function is 4 times x. I'll use 7 plus 8. So that's 8 plus 28, which is 36. Then you go the other direction, f of 0 first instead of g of 0. So you got f of 0, doing this one, g of f of 0. So g of f of 0 is 8, and then g of 8 is this equation. So the reason this is 8 is 4 times 0 is 0, so you get 0 plus 8, which is 8. G of 8 would be 7 minus 8 squared, which is 7 minus 64, which is negative 57. So that's the answer. Okay. Do the same thing over here. So g of 0, plug a 0 and we'll get 4. 4 minus 0. And then we do f of 0. Well, f of 0 is going to be 7 because you get 5 times 0. So, this one is, so let's go back and do the first two again because I didn't. So f of g of 0 is 36. Here, g of f of 0 is minus 57. And here, f of g of 0 is 7. Now the last one, we're doing g of f of 0. So we have to do f of 0 first. So f of 0 is 7. 5 times 0 is 0, plus 7 is 7. And then we do g of 7. And I just realized that the last one wrong, so let's fix that. We need to do g of 7, not g of 0. It's like, what's going on here? So g of 7 is 4 minus 2 times 7 squared, which is 4 minus 2 times 49, which is 4 minus 98, which is negative 94. Okay, now going back to do the last one here, f of 0, we're doing g of f of 0. So f of 0 is 7, and then we do g of 7, which is 4 minus 2 times 7 squared, Something doesn't seem right here. G of 0 is 4. I still got that one wrong. Okay. Let's start that one over completely again. Okay. So we're going to do G of 0. G of 0 is 4. Then we do F of 4. So that's 5 times 4 plus 7, which is 27, and therefore F of G of 0 is 27. And then down here we do F of 0 first instead of G of 0. So F of 0 is 7. And then we do G of 7, which is 4 minus 2 times 7 squared, which is 4. 7 squared is 49, so 2 times 49 is 98, so you get negative 94. Okay, so that's it. So G of F of 0 is negative 94. Okay, what I'm going to do here is I'm going to switch these out. So I'm going to erase this part right now, this whole part here. Oh, I don't need to because it's a function, so I don't have to put what's up there. Okay. So we're doing F of G of 0. This question mark. So G of 0 is 12. Just taking the constant part. And then we do F of 12. So that's the square root of 12 plus 4, which is square root of 16, which is 4. And then we can do G of F of 0. So we do F of 0. So that's the square root of 0 plus 4. Square root of 4 is 2. Then we do G of 2, which is 12 minus 2 cubed. So that's 12 minus 8, which is 4. So G of F of 0 is 4. Up here, F of G of 0 is also 4. How about that? Just a coincidence. Okay, last one here. We want F of G of 0. So we're going to do G of 0, which is 3, because that goes to 0. Then you're going to do F of 3, which is 1 over 3 plus 2, which is 1/5. And so that's 1/5. And then we're going to have G of F of 0. So to do that, we need to do F of 0 first. So that's 1 over 0 plus 2, that's 1/2. And then we'll do G of 1/2. So we get 4 times 1/2 plus 3, which is 4 times 1/2 is 2. 2 plus 3 is 5. So G of F of 0 is 5. Okay, let me just double check my answers here. Make sure I got the same thing. Went through these before. Yep, that looks right. Okay, so that's it.